Hi, this is John Linneball from John Linneball Tutoring, and this is Barron's SAT, Chapter 6P, Counting and Probability. Here's my contact information, and let's get going. Disclaimer, I have nothing to do with Barron's or the SAT. I don't work for Barron's Publishing. The book that I'm referring to here is the Barron's SAT Premium Study Guide, which is the 30th edition of Barron's SAT book. But if you have the 29th or the 28th, that should do just fine. Most of these problems are exactly the same. But anyway, I don't work for Barron's. I don't make money if Barron's sells more books. I don't own the trademark to Barron's, the SAT. Barron's is an independent publishing company that has nothing to do with me. SAT, of course, is a trademark, copyright, whatever, of the College Board, and I don't work for them either. I believe all I've done here is legal under U.S. copyright law, especially the fair use exception for scholarship, criticism, and commentary. And I really like Barron's books. I use them with all the kids that I tutor for the SAT. Definitely buy them if you're preparing for a test. And really, no, I don't work for Barron's or collect any royalties or commissions if you buy their books. They're just good books and they're worth having. So let's go to page 658, question 1. Let A be the set of primes less than 6 and let B be the set of positive odd numbers less than 6. How many different sums of the form A plus B exist where A is a member of A and B is a member of B? Well, let's list the primes less than 6. Primes are positive and 1 doesn't count as a prime. And a prime is defined as a positive integer with only 2 factors, 1 in itself. So we have 2, 3, and 5, because remember, 1 doesn't count as a prime number. So we can see in A we have 2, 3, and 5. And then B, positive odd numbers are 1, 3, and 5. So that's also in B. 3 and 5 are in A and B, so that's why they're in the overlap area of this little Venn diagram that I've drawn. So now we need to add everything up. Well, first we can start with the primes. We have 2, 3, and 5. Well, okay. 2 plus 1 is 3. 2 plus 3 is 5. 2 plus 5 is 7. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 5 is 8. 5 plus 1 is 6. 5 plus 3 is 8. And 5 plus 5 is 10. So we see that 6 and 8 repeat themselves, so we can cross out a 6 and an 8 like there, and that leaves us 3, 4, 5, 6, 7, 8, and 10, which is 7 numbers, so the answer is 7. All right, let's look at the birth and death problem, page 658. Dwight Eisenhower was born on October 14th, 1890, and died March 28th, 1969. What was his age in years at the time of his death? So they're just asking how old he was when he died. Normally, we just truncate the age in years when someone asks us how old we are, meaning we don't say, I'm 17 years, 11 months, and 27 days old. We just say, I'm 17 until our 18th birthdays, even though in this case, we'd be closer to 18 than 17. So did President Eisenhower die before his birthday in 1969? Yes, he did. So we subtract 1890 from 1969, then subtract one more, since he hadn't had his birthday yet in 1969. So he was 79 minus 1, or 78 years old. Mr. White's homeroom. That reminds me of Walter White from Breaking Bad, so that's why I use this picture. This one's easy to reason out. The best way, let's see. This one is easy. Basically, what they're asking is, how many people, okay, you have 27 students in a homeroom. What's the chances that you don't have 3 all born in the same month? So what are the chances of that? So there are 12 months in a year, so the first 12 could have all been born in different months. So we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that's assuming the first 12 are all born in different months. Okay, so again, if we want to maximize the space, we can take the next 12, and even if they were all born in different months, there's only 12 months in a year, so you'd have to have number 13 was born in January, 14 in February. Yes, I realize 13 could have been born in a different month, but even if they're all born in different months, then fine. You have a 13th born in January, 14th born in February, and so on until you get 22, 23, 24. Number 24 is born in December, so you have 3 left. So for the last 3, they have to have born in the same month of at least 2 students, because there are only these 12 months of the year to use. So even if you spread them out as much as possible, each one of these is going to have to go into a month that's populated by 2 other students. So the probability of 3 students being born in the same month in Mr. White's homeroom is 100% or 1. It means complete certainty. All right. Marbles in a jar. So here we have a jar with 5 marbles in it, 1 red, 1 blue. So we got red, blue, green, and yellow, and 1 white. Okay, there's no white one in this picture. Sorry about that. Anyway, if 4 of the 5 marbles are removed, what is the probability the yellow marble was removed? So sometimes it's easier to figure out the probability of something not happening than subtracting that from, subtracting that from 1. So anyway, what you can do here is, all right, so let's figure out the probability of the yellow not being picked. Well, we know that since 4 are coming out, there's going to be the 5th one left behind. So assuming that everything else is equal, if 4 of the 5 are removed, each marble has a 1/5 chance of being the marble that's not removed. So that means the yellow has a 1/5 chance of not being removed. Since we want the probability of 1 marble's being removed, it doesn't matter that it's the yellow one, since it's going to be the same for any one of these marbles. We just subtract the probability of it not happening from 1, which is 1 minus 4/5, which is 4/5, choice C. Problem number 5, page 658, the cafeteria special. The cafeteria has a lunch special where you can get soup or salad, a sandwich, coffee or tea, and a dessert. If the menu lists 3 soups, 2 salads, 8 sandwiches, and 7 desserts, how many different lunch specials can you get? So 2 lunch specials are different if they vary in any way. That is, if you get exactly the same lunch, but one has coffee and one has tea, they're not really exactly the same. They're different. So if they're different in any way, they're different. So first, if we have to add the number of soups and salads, since it says soup or salad, that's really tricky, huh? Because you would just figure, if you're not reading it carefully, you might not read it that way. So you add 3 and 2, so there's 5. Second, coffee or tea counts as a choice with 2 choices. So that's 2 right there. Assuming they only have 1 kind of coffee, 1 kind of tea. They would have to tell you if they had more than 1 kind of coffee or 1 kind of tea. So there are 2 beverages there. And then third, we line up all the choices. So we have 5 soup or salad options, then 8 sandwiches, 7 desserts, and 2 choices of beverage, that is tea or coffee. So we get 5 times 8 times 7 times 2. 5 times 8 is 40, times 7 is 280, times 2 is 560. So the answer is D in your book there. You need cooling, baby, I'm not fooling. Problem number 6 on page 658. You need cooling. Well, the printer really needs cooling. We have a printer that can print 1 page in 5 seconds, then it shuts down for 3 minutes to cool after every hour of operation. How many minutes? So it's really important to pay attention to time units and any kind of unit, distant units, because they can have you convert one to the other. And so make sure that you circle or underline what units your answer has to be in. So how many minutes are needed for the printer to print 3,600 pages? Well, first note that they want minutes, not seconds or hours. So there are a few ways we could do this, but let's figure out the time in hours since we need to know how many 3-minute cooling periods we have to add in. I'll show you that in a minute. So we have 3,600 pages times 5 seconds per page times 1 minute per 60 seconds because we want to convert it to minutes, and then times 1 hour per 60 minutes because what we want to do is convert everything from seconds to hours. So you have 3,600 pages times 5 seconds. The reason that it's crossed out is because there's a page on the bottom. We have 5 seconds per page. So there's this page on the bottom, page on the top of this fraction. They cancel out. Seconds, well, okay, we have 60 seconds and we have 5 seconds here. So I'm going to have 5 seconds per page times 1 minute over 60 seconds. So this seconds, the 5 seconds is on the top, 60 seconds is on the bottom, those cancel out. And then we have 1 minute on the top and we have 60 minutes on the bottom, so the minutes cancel out. So you end up with 3,600 times 5 times 1 hour over 60 times 60 because all these units cancel out. So 60 times 60 is 3,600, so you have 3,600 times 5 over 3,600. Obviously those cancel out, so you just end up with 5 hours. All right, since we know we need 5 hours, that's 300 minutes. And probably the easiest way to do this is to draw a little diagram like probably most computer science majors would do. So we can draw 5 boxes to represent the 1 hour or 60-minute periods. So we have 1 hour, same as 60 minutes. 2 hours, that's 120 minutes. 3 hours, 180. 4 hours, 240. 5 hours, 300. So we have 3, 3, 3, 3. Okay, because there's 3 minutes here where it has to cool, another 3 minutes here, another 3 minutes here, another 3 minutes here, between 4 and 5 hours. Notice it will have to cool after 5 hours, but we don't care because we're done printing. That's the copy shop or whatever, or the office's problem, not your problem. So, you can just grab your stuff and go and do whatever you have to with it. So, we have 5 hours, which is 300 minutes, plus 4 3-minute periods, which equals 312 minutes. All right, number 7, page 658. How many ways from A to X if you could only go up and right? All right. So the red is the path I chose. So this one goes like this in the first one. Then we can go up, and instead of going up here, we just go to the right in the middle and then go up on the end. Then we have one where we go all the way to the end on the bottom and then just go all the way up. And then we have one that goes zigzag like this. And we have one that's kind of the mirror image of that, where you go zigzag like that. And then we have one where we go to the middle, go all the way up, and then go the rest of the way to the right. And this last one I used, put here, but didn't use it. So there's 1, 2, 3, 4, 5, 6. 6 different ways you can do that. Problem 8, page 658. You have a jar with 20 marbles, 4 red, 6 white, and 10 blue. And how many must you remove to be sure you have 2 of each color? Well, answer, imagine you're doing this in the dark and you have the world's worst luck. You have to be sure that you got 2 of each kind. So since you can't see the marbles and you are incredibly unlucky, you probably pulled all 10 blue marbles first. Then you pulled all 6 white ones for a total of 16. Then and only then you pull the 2 red ones because there aren't any others left. The total is then 16 plus 2, which is equal to 18. All right, so problem 9, page 659. N people tried out for the school play. At the audition, K went before Judy, so K is another number of people, who went before Liz, and N people followed Liz. How many people tried out between Judy and Liz? Well, first of all, Judy must be the K plus 1th, or K plus 1 ND, whatever, person in line. Liz is the N minus M nth, or I guess I could have said N minus M d person in line. Therefore, the number of people between Liz and Judy would involve the number N minus M, because that's going to be Liz's number, minus K plus 1, which is Judy's number. However, we're excluding Liz and Judy from that number because they can't be between themselves and someone else. You have to have another person between you. You can't be between you and the person immediately next to you. And that person also can't be between you and that person. So we have to subtract an additional 1 person, which could be Liz or Judy, depending on your point of view. All right, so the number of people between Liz and Judy is N minus M minus K plus 1 minus 1. So it just becomes N minus M, and then we're going to distribute this minus to the K and 1, so we get minus K minus 1 minus 1. So that becomes N minus M minus K minus 2. All right, an easier way to do this is just plugging in numbers. So let's say 10 people tried out for the play. So I've got a producer, a director, and then these are the 10 people who are auditioning. So let's say 3 went before Judy, so number 4 here is Judy, and then 2 went after Liz, so Liz must be number 8 because there are 2 people after her. So we know the order is 1, 2, 3, 4. Okay, there's Judy. Number 4 is Judy. 5, 6, 7, and then 8, which is Liz, and then 9 and 10. So what we do is we can just count and see people. 5, 6, and 7 went between Judy and Liz, so we know the answer is 3. Then we just use 3 as the value for K, 10 as the value for N, 2 as the value for M, and we try these values in each answer choice. So N minus M minus K minus 2 is 10 minus 2 minus 3 minus 2, which is 10 minus 7, which is 3. It works. Problem is we have to check the other answers when we use this method to see if any other answer also gives us the right answer with these numbers. And if we do, then we have to either plug in different numbers and plug them into the 2 choices that both work with our initial numbers, or hopefully at that point you'll figure out how the variables relate to each other and just be able to answer the question. Anyway, B is N minus M minus K minus 1. Well, wait a minute. that's just going to be 1 more than n minus m minus k minus 2. So we really don't have to do any additional math other than recognize, well, if minus 2 is 3, then if this whole thing minus 1 must be equal to 4 because you're subtracting 1 less, so it's the same as adding 1. Since it's just choice A plus 1, no, we know that's the wrong answer. N minus m minus k, well, that's the same as if you added 2 to the first choice. So that would give you 5. That's no good. And then n minus m minus k plus 1, you're actually adding 3 to this because negative 2 plus 3 is equal to plus 1. So that's choice A plus 3, so that's 6. Not bloody likely. Okay, so great. We know that this is the right answer because none of these other choices worked with the numbers that we picked. All right. Problem 10, page 659. In the figure below, each of the small circles has a radius of 2. The large circle has a radius of 6. If a point is chosen at random inside the large circle, what is the probability it will be inside the yellow region? Well, answer, you should know that the formula for the area of a circle is A equals pi r squared. That is, area is equal to pi times the radius squared. So the area of the large circle is 36 pi because we know the large circle has a radius of 6. And the two small circles have a radius of 2. You may notice that this is not drawn to scale. On the SAT, they would tell you it's not drawn to scale. And remember, when they tell you it's not drawn to scale, what they mean is we are messing with you. So you wouldn't be able to figure this out just by looking at the relative sizes of these. Anyway, if this has a radius of 2, then the area must be pi r squared, so that's going to be pi times 2 squared, which is going to be 4 pi, because it's going to be 2 squared is 4 times pi. Since there are 2 of them, we just multiply that by 2, so it's 8 pi. So then the chances of something that a point in the big circle here also being a point in one of the small circles is just going to be 8 over 36 because the pi's cancel out automatically. And we can make this, so this is 8 is 2 times 4, 36 is 9 times 4. So the 4's cancel out, so we just end up with 2 over 9. The area formula is in the box at the beginning of each math section on the SAT, but please memorize it for one reason. If you're planning on taking the ACT, it's not on there. They don't give you formulas like that on the ACT. And also, it's going to save you a few seconds at least. Every second you save on the SAT or even the ACT is going to be time you can use to solve another problem. So please do not allow yourself not to know this. Besides, it's easy, pi r squared. Think of a pizzeria that sells square pizzas. Haha, pi r squared. Ah, but then would it be round? People would say, well, wait a minute, that's the formula. So anyway, no pi r squared for the area of a circle. Problem 11, we have 100 people in line. Andy is person 37, Ali is person 67. What's the probability of a random person being between Andy and Ali? Well, of course you're going to have to subtract 37 from 67, so 67 minus 37 is 30, that's easy. But what you have to do is you have to subtract one more because we're excluding both Andy and Ali. Because we're not including them because we just want the people who are between them. We don't want Andy and Ali themselves. So that's going to be 29 because it's 30 minus 1. Therefore, the probability is 29 over 100 because remember, there's 100 people in line. And you wouldn't actually have room to grid this in as a fraction, 29 over 100, so you would have to grid it in as 0.29. And one way to do this is if you can't remember, use the same trick we did before, where you have 10 people and say Andy is 3, Ali is 6. Okay, we can see that there's only 2 people. Oh, okay, so this must be the one where I have to subtract 1. And then you just subtract and you remember they also have to subtract 1. So that is how you can keep that straight in your head if you're asked something like that. Problem 12. How many four-digit numbers have only even digits? We know numbers generally don't start with leading zeros, so we know the first digit would have to be 2, 4, 6, or 8 to qualify. The other 3 digits can be 0, 2, 4, 6, or 8. So since only 4 can be in the first place here, 2, 4, 6, or 8, that's 4. All the other ones are 0, 2, 4, 6, or 8, so that's 5 times 5 times 5. 4 times 5 is 20, times 5 is 100, times 5 is going to be 500. So there are 500 qualifying numbers with all even digits. Now we could take this problem and turn it into a probability problem by asking, what is the probability of a 4-digit number having all even digits? It's easy enough. We know there are 9, because remember, no leading zeros. times 10 times 10 times 10, so there are 9,000 four-digit numbers. So the probability of any given four-digit number having only even digits is 500 over 9,000, which is 5 over 90, which is 1 over 18. Problem 13, page 659. How many ways are there to arrange the letters in the word elation if the first and last letters must be a vowel? So the vowels are A, E, I, O, U. The vowels in the word, which is what I meant here, is the vowels are E, A, I, and O. So there are only 4 in this word. There are 7 places where we can put a letter, slots or blanks. The first and last slots must be vowels. So we have 4 choices for the first slot. That's got to be E, A, I, or O, and the last one has to be one of those letters that we didn't already choose for the first slot. So we have to multiply them all for all the combinations. Since there are 2 vowels that can't be in the middle, we have 4 times 5, because there are 5 letters left, times 4, times 3, times 2. And once we get to this one here, right before the 3, that's a 1 because there's only 1 letter left. So if we multiply this out, 4 times 5 is 20, times 4 is 80, times 3 is 240, times 2 is 480, times 1 is still 480, times 3 is 1440. If you don't believe me, check it with your calculator. Okay. Questions 14 and 15, page 660. In the diagram below, or in the diagram actually next to it here, A is the set of positive integers under 20. So this here is integers under 20. B is the set of positive integers containing the digit 7, and C is the set of primes. So you'd probably want to write a little note here, like put less than, make a less than sign, 20. And then B, you'd probably want to put 7 or has 7 in it. And then C is going to be the set of prime numbers, so just write prime. Okay, so how many members does X have? Well, X is between A and C, which means set of positive integers under 20, and C is the set of primes. So we need primes under 20, but notice they're not in set B, so they can't contain the digit 7. So that's going to be 2, 3, 5, notice not 7, 11, 13, and then 17 we can't have, and 19, so it's going to be 3, 6, so there are 6 members, so that's your answer. And then in the diagram below, question 15, this is the same diagram, same description. What is a number less than 50 in region Y? Well, okay, we see it's in set B, so it has to contain the digit 7, and it's in set C, which is the set of primes, so we need a prime number under 50, but also it's not in this under 20, so it has to be over 20 and under 50 and contains a 7. So as it turns out, 37 and 47 are both prime numbers that would work. You probably could find that pretty quickly because you just go, okay, well, 27, no, 37, oh yeah, 47, yeah, and it has to be less than 50, so you probably figure it out pretty quickly when you realize that 37 and 47 don't have any factors other than 1 in itself. Did you find this video useful? If you did, please like it and subscribe to this channel. Neither action costs you anything, and you'll be alerted about my new videos. Why do I care? Well, it's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours. That's 240,000 minutes. Hey, remember those units of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time, and I still don't have anywhere near 1,000 subscribers. Last I checked, it was about 653. So, for the same reasons, you are not only welcome, but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism and suggestions for new videos. I reserve the right to delete comments from and block those who specialize in destructive criticism. Trolls, basically, or things that are off topic, spammers and disturbed people. So, You can contact me on my cell phone, 415-623-4251. You can text me on my cell phone at that same number. You can email me at john@johnlinneball.com, and you can send me postal mail at 1859 Powell Street, number 109, San Francisco, California, 94133. Thanks for watching. Hope you're having a good day.